So, Mr. Bridges, are you there?
Yep.
Okay, just wanted to know. Mr. Hall, are you there? And Mr. Cronin, are you there? Okay, I see your head, a little bit of your head. Okay, just want to make sure. All right. Now, before we get started, we're going to go to our handy-dandy GeoSpace, our Geo Sketchpad, and we're going to start a new section. And if you look in your outline, which I'm trying to find, we are starting 6.4. 6.4. And I want everybody to look at, okay, now we got 19 students. And how many videos? Still got 1, 2, 3, 4. Okay, so we got 3 people that are not have turned on their videos that have just come into class. 2, 3, 4, 5. 5 and 12 is 17. So we got one person that don't have theirs on. So that one person, please turn your video on. And please don't point it to the ceiling. All right, so here is a open. The next step, besides the area between 2 curves, is volume. And here is an example of what we call a disk. Okay, a disk is rotated around the x-axis. And remember, these are disks that are the width of your hair. Okay, now this one's extra wide because we're getting the area from A to B. And if you apply the limit theory and you rotate, that's what it's going to look like. It's going to look like a disk. Capiche? So if you draw this, your disk, each one of your disks, no matter how wide it is going to look like a cylinder. No matter how wide it is, it's going to look like a cylinder. So if I give you a function, and let's say that function looks like that, and I give you, I say, and I rotate it around the x-axis, then it's going to take on the effect of a disk. That's what it's going to look like. The width of the hair is going to be like this. And it's going to get bigger and bigger and bigger, depending on the function. So what it looks like when you get through is more, instead of a line, it's going to look like some kind of a conic section, like a vase or a thing at Thanksgiving, whatever those things are called at Thanksgiving, filled with the fruit and vegetables and stuff. It's going to look something like a vase when you get through. And I suck at drawing, so please don't. So when you go back to the GeoSpace, that's what it looks like. Now this is what we're going to be doing. This is called a disk. So a disk Looks like a disc. Okay, these discs right here, you have the width of the disc. Okay, you got the width of the disc. This is the x-axis. This is the y-axis. The width of the disc is going to be dx. So the width of the disc is going to be dx. You need to write that down. And somebody tell me how to find the volume of a disc. It's the surface area times the height, isn't it? Yes, Hubert. So the area of a circle is equal to pi r squared. Therefore, the area of a cylinder is equal to pi r squared times the height. Everybody with me?
Yes.
So we're going to be using this. The radius when you're going around the x-axis, the radius is equal to the function. Now, it's very important that you understand what I just said there. Okay? Very important. Now, I'm going to take my handy-dandy yellow highlighter. The radius is equal to the actual function because that's the height. So we got r, which is the function. We got h. I'm sorry, yeah. But that's how far you're going. Okay? And we got the dx, that's going to be in the antiderivative. Now, it's very important that you understand and highlight this square because you're going to forget it. So make sure you highlight the square. So for a disk, so take what we just said, and for a disk, what is the antiderivative setup? For a disk, the antiderivative setup is the antiderivative from A to B of pi r squared dx. Write that down because there's your height and there's your width. And of course the pi r squared, that's the area of the circle. And in this case, r is the actual height. That's your function. Now, is this 100% important? It's 150% important. I'm going to highlight this square because you're going to forget it. And you can go around the x-axis as well as the y-axis. And we'll get to that in just a second. So here's an example of a disk problem. Given y is equal to x squared. I'm sorry, square root of x. Revolving around the x-axis. And you're going x is equal to 0 to x is equal to 4. Now all that's given, and the first thing you do is draw a what? Draw a picture, Hubert. Yep, draw a picture. I want you to draw it and label it and put the 0 to 4 on there, and so you can understand what you're doing. So the volume found by a disk is equal to A to B of pi r squared dx. So the volume of this disk, we're going to, looks like that, and we're going to draw a real thin line, for that's the width of my, think of the width of a hair. And we're going to circle that around the x-axis from 0 to 4. So in other words, you got some kind of three-dimensional object looks like a half of a watermelon. Everybody picture a half of a watermelon? That's what it looks like. Be nice if I could draw a half of a watermelon, but there, I'll add the seeds. I can draw the seeds. All right, so the volume of this half of a watermelon is equal to 0 to 4 pi parentheses squared, and that squared is going to be pink, so I don't forget it, dx. V is equal to 0 to 4 pi parentheses squared dx. And what goes in? Well, here is your function. And it's going to go in right there. And that is the, oh Lord, I got tops. So my pen tops, I got them on the wrong marker. It's going to be the square root of x. And that's x to the 1/2. However you want to write it. I don't care. But we all know that decimals, we all know that radicals and calculus don't mix. But what happens to the 1/2 or the square root? What happens to it?
Cancels.
It cancels. All right, I want y'all to finish it. Somebody tell me what you could do with the pi. What can you do with the pi before you even start? 1, 2, 3, 4, 5. We got 5. Well, 4. Somebody just left. Oh, now we got 16 and 21. So 5 people now have turned off their videos. Let's turn them back on, please. Just curious, why do y'all keep turning off your videos? Somebody want to answer? Okay, I'm gonna have to go down the list and kick you out. All right, here we go. All right, do I see Adamson? I saw him a while ago. Where did Adamson go? See, I don't see Adamson now. There he is. Okay, Bickett. Looking for Bickett. Does anybody see Bickett on video? Okay, kick him out. Hate doing this, but that's the rules. Bridges, Bridges, Bridges. There's Bridges. Brown is here. Cronin's ceiling fan is here, and the top of his head. Hull. Anybody see Hull? Lang. I saw Lang a while ago. Where is she? There she is. Isaac, where are you at, Isaac? He's not on video. Let's see, who's left? Martinez. I'm looking for Martinez. Martinez is making everybody dizzy, but there's Martinez.
Sorry.
Nicolini. What are you doing, Miss Martinez? You walking around in the meadow with the daisies and the flowers and feeling all free and happy and go lucky?
I wish.
Somebody needs to sing Born Free while Miss Martinez walks around. Payella is doing some bad class project.
Engineering.
Isaac, are you back in? Hello, Isaac. Let's see, Nicolini, Payella, Perry. Where's Perry? Looking for Perry.
Can you guys hear me now?
Anybody see him? There's Perry. Hey, Perry. Rosaka. Throw your hand up, Rosaka. There he is. Got to wake you up. Smith and Sullivan. I see Sullivan. Let me see Smith. Don't see Smith. There he is. He's in the basement. Tomlin and Viana. Tomlin is there. Viana. Where is Viana? There's Viana. And Williams Madison. Okay, so everybody's here, I guess. Just want to make sure. And you know how else I can tell when people are paying attention? When I remove them from the class and they never come back. That means they're not at their computer. So I don't know why y'all do this stuff, but y'all do. And there's those videos. Why are y'all leaving? Why are you turning off your videos? I just don't understand it. All right. So with that being said, let's finish the problem. So we're here. What can we do with the pie? That means I want y'all to say something. Miss Jones is making me dizzy now. Between Miss Martinez and Miss Jones, I'm gonna fall down.
You can't multiply it by 1 over pi, can you?
No, but we can do something easier than multiply. What can we do with that pie?
Divide.
We can pull it outside the what?
The integral.
Pull it outside the antiderivative, yes. So I'm going to pull it out just to kind of make things easier. So V is equal to pi antiderivative 0 to 4 of x dx. Now, do you see this in the future? Yes. So I'm going to highlight that blue because I want you to make a note of it, because pi is a number and you just take it out of the antiderivative so you don't have to worry about it. So you're going to see that in the future. So we've got v is equal to pi times x squared over 2, evaluated at 0 and 4. V is equal to pi. What happens to the 0? Zero over 2 is 0, so it cancels out. And that leaves 4 squared over 2, which is pi times 16 over 2, which is 8 pi. Units what?
Squared.
Nope, not squared.
Cubed.
Volume is cubed. So that watermelon, that's 4 inches long. Let's say that this slice of this half of watermelon is 4 inches. Then we just found out that the volume, I need somebody to multiply pi times 8, please. What's pi times 8? Give me 2 decimal points.
25.13.
Cubic what? Inches. So this 4-inch watermelon, and I'm just being facetious because we had a formula for the watermelon. So we don't know how wide it is, okay? But the formula gives us that. So a 4-inch watermelon is giving us 25 cubic inches of volume. All right, let's do nerd. Let's do this one. And this is a test question. This is the basic of the basic. All right. So let's do this one. Y is equal to 1 over x. Revolve around the x-axis. And going x is equal to 1 to x is equal to 3. I want y'all to do this one. I'm going to let y'all do it. I'm going to give you, I don't know, a minute and a half. Maybe 2 minutes. I believe y'all can do it because y'all are smart. 2 minutes. And if you can't do it, then that means that you're a failure. Miss Jones finally settled down and sat down. Thank you, Miss Jones. Miss Martinez, I don't know where, she just left. She just said the heck with you. I'm not going to listen to you, Hubert. I'm going to cut my video off, and I'm going to eat me something. Fine, go ahead and eat. I'm going to fail you. I don't care what grade you got in here. Insubordinate. Failure. Time for me to get a dang haircut. I'm having a bad hair day. Miss Lang, are you out on the back porch?
Yes, I am.
Dang old calculus al fresco. You must not live in South Carolina. It's too humid to sit outside.
Yeah, I live in New Jersey.
Yeah. Whereabouts in Georgia, Miss Lang?
I said New Jersey.
I was fixing to say, but you know what? I decided I was going to take my son up to New York for summer vacation. I thought it would be less humid. Oh my God. We about died up there.
Yeah.
So I don't know about New Jersey. New Jersey is closer to the beach, right?
Yeah.
Do you have the Jersey accent, Miss Lang?
I don't think I do. Some people do.
Well,
I think I'm from South Jersey, and I think that's more North Jersey people who have a Jersey accent.
okay. Yeah, we took the train and rode through Jersey, Newark train station. We went through there. Isn't that in Jersey, Newark?
Yeah, that's part of North Jersey.
Yeah. I liked it. In fact, the next time we go on a trip, it's going to be by train. Because I don't like being in a sardine can with wings. Now, back in the 60s to the 80s, you could ride a plane and not be crunched in like a sardine. To hell with that. I ain't doing that. And I always get by somebody that smokes 3 packs of Marlboro Reds a day. Oh, hell no. No, I won't do it. And if you smoke 3 packs of Marlboro Reds a day, your ass stinks. I'm sorry. You stink. All right. I didn't say 1 cigarette a day. I said 3 packs a day. Your ass stinks. All right. So here we go. We're going to sit this guy up. I'm going to pull pi out like that. And that's going to be x to the -1. I'm going to take my pink highlighter or my pink pen, and I'm going to put to the second power, because you got to remember that second power or you will forget it. Dx from 1 to 3. We're going to draw a picture. So from 1 to 3. So that means I'm going to I'm going to make it just a little bit wide so you can see it. There we go. And what's that going to look like? Well, it's going to look like I wish I could draw. I can't draw worth of crap. What will it look like? It'll look like something like that. So I guess you could say, like a morning glory flower or a speaker on an old phonograph, or, turn it up. That's what it looks like. I'm trying. I suck as a drawer. I'm sorry. So it's going to look. How's that? Is that a little bit better? So that's going to be pi from 1 to 3 of x to the what? -2 dx. X to the -1 over -1 times pi, evaluated at 1 and 3.
How'd you get x to the -2? Oh, never mind.
Yeah, you forgot it. You forgot the 2.
No, I did it wrong.
Okay. Don't forget that square. And that's going to be, well, I'm going to go ahead and just do pi. And that's going to be 3 to the -1, which I'm going to reduce this. It's going to be -1 over x to the 1.
I have a question.
Yes.
Can you see me now? Because my phone froze. I heard you, but my phone completely
We see your, yeah, we
froze,
see
and then
your
it
ceiling.
locked me out.
We love your ceiling, Miss Martinez.
Oh.
Yeah. We always see your ceiling when you come on. Okay. All right, go to the next page. That's going to be pi times -1 over 3 minus a -1 over 1. Now remember, what does this guy mean right here? What does that blue line mean? It means what? Subtraction.
Subtract.
Because that'd be the next thing that y'all screw up. Y'all make this a negative and it's supposed to be a positive. So pi -1/3 plus blank thirds. 1 will go into 3. 3 times 1 is 3, and y'all know that. And that should come out to be 2 pi over 3 units cubed. Good job. Y'all are just learning all kinds of stuff in here. I guarantee you some of y'all are very proud of yourselves learning how to find the area like that, because you either never have done it or you couldn't do it before, one of the two. Now, what if I throw this monkey wrench in it? Y is equal to x squared. And we're going y equals 0, y is equal to 4. Rotating around the y-axis. So you got a couple of things that are different here. One, instead of x equals your parameters, you got y equal to the parameter, and that tells you that you're not rotating around the x-axis, you're rotating around the what? Around the y-axis. So there's your disk. And this is going to look something like, it looks like, well, it kind of looks like what we were talking about a while ago. It kind of looks like one of those funnels. Like that.
Wouldn't this be a parabola, not?
Oh, I'm sorry. I suck. You're right. You're exactly right. I'm the one that's wrong. There you go. So it's going to look like that. Like that. And the radius is equal to, again, the function. And dy pretty much is equal to, but everything's going to be in terms of y. So we got to change, since everything's in terms of y with the dy, we got to change the function into terms of y. So we're given y is equal to x squared. We know that y is equal to 0 to y is equal to 4. So 4 is right here. So this looks like a bowl. Okay? This looks like a bowl. So think of a bowl that's 4 inches tall. 4 inches tall. Maybe your cereal bowl. More like a coffee cup, probably. One of those big coffee cups that people drink soup and stuff out of. You know what I'm talking about? Guys, y'all don't know what I'm talking about. You just drink it out of the can, man. These girls, they get this big old mug that's about this big, and they put like soup and stuff in it. All right, so it's 4 inches tall, and it's around the y-axis. So I'm going to highlight that y-axis again in pink, and you need to put something in red right beside it. Take my red pen and put in big letters, solve for what? Solve for x. You got to have your formula in terms of y. So I've got to solve this for x. So I'm going to go over here and do it in red. Y is equal to x squared. Take the square root of both sides. X is equal to the square root of y, or x is equal to y to the what? 1/2 power. Whenever you are rotating around the y-axis, you have to get your formula in terms of y. Not solve for y, in terms of y. So here is my, it's the same line, but I've got it in terms of y. So x is equal to y to the 1/2 power, and we're going from 0 to 4 on y. Now I can plug it in, as long as everything's in terms of y, and the base, the width of my cylinder is dy. So everything's in terms of y. The function, the numbers, the width. Everything's in terms of y. So volume is equal to pi, goes on the outside, 0 to 4 of y to the 1/2 power. Remember, it's what? Squared dy. All right, y'all finish it. The reason I left it in red is because we're in terms of y. So it is different from doing it around the x-axis. So that's why I left it in red. So let y'all finish it. Anybody remember this? Mr. Payella, you remember this from your attempted calculus class?
I don't think I made it that far.
Okay. Anybody remember this from an attempted calculus class?
I do.
Anybody?
It seemed as simple.
I'm sorry, who said that?
Mr. Smith with the rafters.
Okay, what did you say, Mr. Smith? I didn't hear you.
I said I took this one time before, but it didn't seem this simple.
you need to get a T-shirt made and take that into class. That's a nice saying. Yeah, I've seen this before, but it wasn't that simple. Remember me telling you that calculus was not that difficult? It's not. It's just the way it's presented. Okay, so V is equal to pi. And what happens to the 2 and the 1/2? Cancels. And I'm going to rewrite that over here. And the reason I'm writing in red, and I never write in red, is because everything's in terms of y. So pi times y to the 2nd over 2, evaluated at 0 and 4. Four squared over 2 plus 0 or minus 0, doesn't really matter because that cancels. So pi times 16 over 2, and that's 8 pi. Some of y'all got 8 pi and you can't believe it. Mr. Payella got 102 plus 7. He don't even know what's going on. 8 pi.
102.7?
Yeah, that's what you got.
Oh, yeah, for sure.
What project you working on? What class?
It's for AMT 102 and 3.
What is AOT?
AMT is Automated Machine Technology.
Oh, you're in robotics?
Yeah.
Oh, okay. Now, see there? He's doing something else. I'm cool about it. It's when you try to hide the crap. That's when it gets on my nerves. When you don't think I got enough sense to know that you showing the ceiling means that you're either doing something or you left the room. One of the two. Anyway.
I appreciate it.
Yep. Next. Well, let's do this one. I'm going to let y'all do this one by yourself. Y is equal x to the 2/3. X is equal to 0. y is equal to 1. Now, these are lines. Okay, the way I'm writing it, these are lines, so you got to draw it. And you're revolving around the y-axis. Now, the first thing you got to do with this one is you got to draw everything. Just draw it first. Don't try to do anything. Draw it. If a lot of you are wondering why I've been starting class at 12:10ish, it's usually because I have a meeting or I'm doing orientation or advising. That's why. It's not because I'm just being lazy. It's because I'm having something to do something before class. I know some of y'all don't really care, but there's one or two of y'all that gets on your nerves that I start class late. Well, that's because I'm doing something else. All right, I'm going to draw it for you. All right, the function is 2/3, and it's going to look like this. X is equal to 0. Somebody tell me what x is equal to 0. What is that?
The x-axis.
Not the x-axis, but the what?
Or the y-axis, sorry.
The y-axis. So here's x is equal to 0. And what's y is equal to 1? What is that?
A horizontal line at 1.
It's a horizontal line at 1, yes.
No.
So I'm going to draw a and there is my drawing. And I'm going to draw, and when you draw your button, I call it a button, a disc, whatever you want to call it. When you draw it, look at it. And I'll put the radius, I'll put the height on this side this time. What is the radius of this function? The radius is the actual what? The function. Which has got to be in terms of y. What's the height of this function? What's the height? 0 to what?
1.
0 to 1. So the drawing will tell you what to do. You just got to, discern from looking at it. We know that this is around the y-axis, so that tells us we got to put this in terms of y. So we got to solve for x. So parentheses, 3/2, 3/2. So x is equal y to the 3/2 power. Okay? So now you're ready to set it up. Go ahead and set it up. I drew it for you. Now you need to set it up. Everything's in terms of y now. Oops, I'm sorry. There. Now everything's in terms of y. Don't forget your square and don't forget your pi. This looks like, what does this look like? This looks like a, yeah, it looks like a vase without a base to it. That's what it looks like. I think I'm getting better with my drawings. I doubt it.
Yeah, this is this shows Sex and Life. If you guys are not
What?
watching this, I advise you guys to watch this. This is gives you a good outlook of the beta bucks, alpha fox, beta bucks. It's simple. Of course.
Say again, Mr. Perry. I didn't catch all that. Were you talking to yourself, Mr. Perry?
No, that was a YouTube video.
That was what?
That was a YouTube video.
Okay. You could say that looks like a top, you know, a top that you spin. That might be before some of y'all's time. I don't know if y'all know what a top is.
I suppose them all the time.
Say again?
I used to play with them all the time.
Yep. What's sad is some people don't even have any idea what we're talking about. Okay, I'm going to do this in red since it is Y. So volume equals pi from 0 to 1 of y to the 3/2 power squared dy. And of course, what happens to the square and the 2?
They cancel.
Cancel. And now you've got pi times 0 to 1 of y to the 3rd dy. And that's going to give you y to the 4th over 4. Evaluated at 0 and 1 times pi. And the 0 does what? Cancels out. So that's 1/4. So pi over 4. This stuff ain't hard, is it?
Not really.
Let me ask you a question. What helps you with these problems more than anything?
What do you mean?
On this page, what helps you either start the problem or understand the problem?
Oh, I'm drawing it.
Drawing a picture. I know, I've known calculus students that this is beneath them. They don't need to draw a picture. And they don't get the problems right. Draw a picture. Now, what have we just talked about? Well, we just did a class on disk. Okay. What's a disk with the hole cut out called?
Donut.
I'm sorry, what?
Donut.
Well, and food-wise, yes, it's a donut. But what mechanically is that called? A disc with a hole cut out. A washer. You know, that goes on a bolt. It's called a washer. That's what we're going to study next. And I'm going to shut up for today because it's 1:15. I'm going to let y'all go after I check the names and who's here this week. Shouldn't be too many names.